Hello, you're welcome to my channel. Now in this video, we want to find the values of x, or the real numbers that will make this function to be defined. That is, we want to find the domain of this function. Good. We have 3x divided by the fourth root of 16 minus 2x. So this function will be undefined if the denominator is equal to 0. That is, if the fourth root of 16 minus 2x is 0. Good. So we've equated this to 0, which is what you don't want. That means the values of x we are going to get from here, we will not want them, right? So we will be taking every other real number except the values of x that will make this denominator to be equal to 0. Great. Well, we solved a couple examples on functions, and we've been dealing with square root most of the time. Now, the square root of a negative number, the result does not exist in the set of real numbers. Likewise, the fourth root of a certain number, likewise, the sixth root, the 8th root, or the eventh root of a certain number. So if you have n, which is the index of a certain radical sign, and that n is an even number that is more divisible by 2, then whatever you have inside should not be less than 0. Good. So the fourth root here will play the same role as the square root. And when we say the fourth root of something, the output cannot be negative, sorry. When we say the fourth root of something, the output cannot be negative. Now, generally, the fourth root of a certain number, let me put it down here, the fourth root of, let's say, certain function, okay, let's just use the identity function, the fourth root of that is going to be either bigger than 0 or equal to 0. There is no way we'll get the fourth root of x to be less than 0, right? Provided that x is a non-negative real number. Alright, so using that fact, it means that 16 minus 2x cannot be less than 0. It can only be bigger than or equal to 0. Alright? So if it is not equal to 0, then it must be bigger than 0. That's all. Now, we say that if this is equal to 0, it's going to give us a problem in the denominator. So that means the only thing we should consider is that this should be bigger than 0. Right? Great. So, that tells us, if the fourth root of this is bigger than 0, then this is bigger than 0. That is 16 minus 2x is bigger than 0. If we take the fourth root of a certain number, and the result is bigger than 0, then that number is bigger than 0. Note, it is only a fourth root of 0 that gives us 0. So you notice that fourth root of, should I write this? See that fourth root of a number called a is equal to 0, even only if that a is 0. So this is an important thing to note. The fourth root of a number is only 0 if that number is 0. Good. Great. Otherwise, that number is bigger than 0. So 16 minus 2x is bigger than 0 from that fact. From here, we can make x to stand alone. I would move this negative 2x to the right hand side of the inequality. You're going to have 16 is bigger than 2x. And then we can divide both sides by 2 from there. That means 8 is bigger than x. Right? You know, dividing both sides by 2 will take care of the coefficient of x, which is just 2. Now, if 8 is bigger than x, it means that x is less than 8. Right? So this tells us that x is less than 8, given that 8 is bigger than x, right? Right, great. And now from here, we'll be talking about all real numbers less than 8. So, x is less than 8, and then the domain of that function is going to be a set of real numbers such that x is less than 8. Great. So whenever we put in a real number that is less than 8, then we can get the output of this function to also be a real number. But what happens if we plug in a number that is either 8 or bigger than 8? This denominator will either be 0 or bigger than 0. And in fact, this function will be undefined for any real number bigger than or equal to 8. Good. So this is a nice way to represent this function. Or better still, we can use the interval notation to say that the domain will be that all real numbers belonging to the interval from negative infinity all the way down to 8 with 8 excluded. That's why we're using the parentheses. If 8 was to be included, in other words, if we were to have less than or equal to x, less than or equal to, we'll be using a closed bracket, this kind of bracket. But since we do not include 8, we are using a parenthesis at 8. Great. Alright, good. Okay, thanks for watching and please subscribe to my channel.